Volume and surface area. Okay, so I am designing a patio for my home here in Africa, and I'm going to put a barbecue in the patio as you see here. So this is a plan view. This is a top view of my patio. You see my patio is rectangular, overall dimensions of 23 feet by 15 feet. So we can say that the area of my patio is going to be, since the rectangle is 23 times 15, that's 345 square feet. And my barbecue area, which is inside of or within the patio area, is 7 feet by 5 feet. So the area of my barbecue is going to be 35 square feet, because again, this is also a rectangle. Right? So this part that is not the barbecue will contain stone tiles. So if I want to find what that area is, the area of the tiled area, that's simply going to be the area, the overall area of my patio minus the area of my barbecue. So I do 345 minus 35, and that gives me 310 square feet of tiles. So if I want to purchase tiles that are 1 square foot each, then I will need 310 tiles in order to cover this area. Now, each brick in the barbecue, so the patio area is going to be tiled in stone tiles, but the barbecue area is going to be made of brick. And each brick in the barbecue has the following dimensions. It is 12 inches wide, 6 inches long, and 12 inches high. Since we're dealing in feet here, it can be useful to convert these dimensions here to feet. So 12 inches is equal to 1 foot, 6 inches is half a foot, 0.5 feet, and again, 12 inches is a foot. All right, so another thing that we are concerned with is the design of the base of this barbecue. So this is the overall plan view, but the base will be made of bricks, and it'll be actually 4 feet tall. And so when the bricks are laid, we're going to stagger them so we can get a solid structure, and it's going to look something like this. Okay, so this is the layout of our barbecue, our brick structure. So again, 7 feet wide or 7 feet long and 5 feet wide. And then we can look at this base is, like we said, it's going to be made of several layers of brick. So we can look at one layer of this brick in 3D or isometric form, and that would look like this. All right, so this is a 3D isometric view of our brick barbecue base, and we will need for our base to be a total of 4 feet high. So we see that one layer is 12 inches or 1 foot. So we will need a total of 4 layers in order to make up the entirety of the base. So this is what a 3D rendering of the base of our barbecue would look like. So notice again, it has the same dimensions as our plan view over here, 7 foot by 5 foot, but we've included a third dimension, which is the height of 4 feet. And we see here, we have the 4 layers of bricks represented. So with this, we can calculate the volume of our base. Volume being in 3 dimensions. So we'll need the area, which we already know is 35. So 5 feet times 7 feet gives us the area of the base. And we take that area of the base and we're going to multiply it by the height. That's our third dimension, is the height. So we take that 5 times 7 is 35. 35 times 4 is 140. And the units here will be cubic feet, or feet to the third power. The 3 here is related to the fact that we have 3 dimensions. We have height, width, and length, as compared to area, where we only have 2 dimensions. We have width and length, or base and height, and those 2 dimensions are why we give area in units of square units, square feet, square meters, square miles, square kilometers, and so forth. All right, but for volume, units are cubed because we are now dealing in 3 dimensions. So when we say volume, we're talking about a measure of the amount of space that a solid figure takes up. So this volume is in some ways related to, you can think about it as the number of bricks and our base. So we see here we have one brick, and that one brick takes up a certain amount of space. We can use these dimensions, the dimensions of the plan area of our barbecue as well as the dimensions of our brick, to determine how many bricks will be necessary in order to create this shape. So to determine the number of bricks, what we're going to do is we're going to take the area of our barbecue, which we found as 35 square feet, and that's essentially per layer. Okay, and we're going to divide that area of the entire barbecue by the top area of a single one of our bricks. So we can calculate the top area of a single brick by using the dimensions of our brick that we have here. So we see that the top dimension is 1/2 foot by 1 foot. So that gives us an area per brick of 1/2 of a square foot. Okay, and that is per brick. And so if we take 35 square feet and divide it by 1/2 a square feet, we get 70 bricks. So that means that one layer of our barbecue, a single layer here, is made up of 70 bricks. All right, but then we know that we need 4 layers in order to make up our entire base. So we're going to multiply this by 4 layers. And so that's 70 times 4, and that gives us 280. All right, so the total number of bricks that we're dealing with is 280 bricks. All right, and again, you can think of this as the number of bricks as being related to the total volume, in that each brick has a volume as well. So we can determine the volume of a single brick by, again, multiplying length, width, and height. So if I do 1 times 1 times 0.5, I get that the volume of a single brick is 0.5 cubic feet. All right, the volume of a single brick is 0.5 cubic feet. So indeed, if I take that 0.5 cubic feet and I multiply it by the number of bricks, 280 bricks, well, 1/2 of 280 gives me back the volume that we calculated initially, which is 140 cubic feet. Another important measurement that we use is surface area. So we find the volume of 3D solids, and we find the surface area, we find the area of 2D polygons. But of course, 3D solids are indeed composed of 2D polygons. In fact, there's a special name that we give to a solid that is formed from polygons, and that is called a polyhedron. Okay, so anytime we have a solid, a 3D figure that's formed from polygons, we call that a polyhedron. So here is a rendering of the finished version of the barbecue from the previous example. So we have a base that's 4 feet high, and we have an additional couple of feet on top of that. And so we see what that finished picture looks like. And what I've done here is I've shaded the different, what we call faces of this barbecue. So if we count it up here, if we want to know the total number of faces, we can say there's the yellow face, and then there's the opposite side of that, which we can't see. So that's 2. The orange face, and then the opposite side of that, which is at the back that we can't see. So that's 4. Then we have this top face that's purple, and then we have the opposite face, which is at the bottom here that we can't see. So that's 6. But then we also have these faces on the inside. So the green one makes 7. This black is 8. The one opposite to the green one that we can't see is 9. And then the red makes 10. So this particular polyhedron has a total of 10 faces. And each of these faces has a surface area. It has an area. And if we combine all of the area of all of the faces of this polyhedron, we get what's called the surface area. So the surface area is really not a new concept. It's just the idea of area, and remembering or taking into account that 3D solids or polyhedrons are composed of polygons. So we're basically finding the area of each polygon in a polyhedron and summing that to get our surface area. So for example, we can look at this first face here that is in orange, all right? And we can divide it up into smaller sections, smaller rectangles. So the first thing that I notice is I notice a rectangle here. Let's see if I can get that a little better lined up. I notice a rectangle here, yeah. And if I look at this rectangle, I know that the length of the rectangle is 7 feet, and I need to figure out what the height is. So we can say the base of this rectangle is 7 feet, or what is the height? Well, we know that the overall height of this figure is 6 feet. This 6 feet height also corresponds to this 6 feet height, also corresponds to this 6 feet height. So we know that the total distance here is 6 feet, and they give us that this portion is 2 feet. That must mean that this missing piece is 4 feet, right? So this is going to be 4 feet. So with that, we can determine this portion of the orange face is 7 times 4, which is 28. All right, so this is 28 square feet. And then we need to figure out what the surface area of these two portions are. And so here we see that the height here, this is a rectangle, of course, the height here is 2 feet. The width here is 1.5 feet. So this area here is going to be 3 feet. And likewise, we're given that this width here is 1.5 feet. This is going to be the same height, 2 feet. So this is also going to be 3 feet. So if we were to find the area of the orange face, okay, so the area of the orange face is going to equal that 28 square feet plus 3 feet, 3 square feet plus 3 square feet. So that's 6 square feet. So that's going to give us a total area of 34 square feet, right? So that's just for this one face. Then we can come over here, we can determine the area of the orange face. We can see that it's a rectangle with dimensions of 6 by 5. So we can say that this yellow face, that the area is equal to 6 times 5 again is 30 square feet. And we can keep in mind that this area is going to be mirrored on this opposite side here that we can't see it. So we can remember to multiply this by 2. We can't do that with the orange area because the area opposite to it is going to be different. In fact, we can determine this area now. So we can see that we can imagine it's a rectangle. And the width of it is going to be 7 feet. And the height is going to be 6 feet. So we can do 6 times 7, and we can determine that this area back here is equal to 42 square feet, all right? And we can continue this process. We can find the area of the purple. We can find these areas on the inside. We can find the area of the base. It's 5 by 7. And once we get all of those areas and add them all up, then we have what's called the surface area. So volume and surface area are the main two measurements that we're concerned about when we're dealing with 3D solid figures or polyhedrons.